Hi, everyone. My name is Helen Schmidt, and I'm one of the co-directors of the Coding Outreach Group here at Temple University. If you've clicked on this video or are following along with our live workshop tutorial, I imagine you're interested in making maps. Map making is an age-old practice, but today we'll talk about how we can leverage R, a computer programming language, to create and customize our own digital maps. Throughout this tutorial, we will cover the basics of map making, including design principles that are important to follow regardless of the medium you're working in. We will then pivot to creating maps using some basic and advanced R programming techniques, understanding geospatial data, and discussing how to leverage geospatial data to add features to a basic map. I'll then close out by sharing some opportunities to learn about digital cartography and take part in online map-making challenges. If all of this sounds interesting to you, I invite you to stick around for the rest of the tutorial. Before we get started with any map making, let's go over some key concepts like defining cartography, outlining key features of maps, and detailing what I mean when I talk about geospatial data. Cartography is the practice of making maps with the goal of communicating geographic information effectively and creatively. When you think of early examples of maps, these were often hand-drawn using information gathered via surveying techniques. Today, maps are much more accurate geographically, using images and data often gathered from satellite imagery. A single map obviously can't contain all the geographic information in the world. Therefore, when making maps, map makers need to strike a balance between what information to focus on and how to subjectively, yet creatively, design their map to make that information understandable for those who are looking at the map. It's important to realize that all maps contain some amount of bias as a result of these design choices. Take the Mercator projection as a classic example. In order to project the round Earth onto a flat two-dimensional surface, this projection enhances the size of land closer to the poles, so the North and South Pole, and minimizes land that's closer to the equator. This projection is widely used and widely criticized today, as its disproportionate representation of areas like North America and Europe can imply greater power and importance. With this in mind, there are a lot of decisions that one must make as a map maker. Let's review some key elements that you may want to manipulate or consider in order to help your map tell its story. Let's start with scale. Scale reflects the relative area depicted in a map relative to its real geographic size. You can think of scale as a compromise between the amount of detail in a given area and the expanse of geographic information that you want to show. A highly detailed map showing certain species of a flower may be more zoomed in on just a few square miles of land, whereas a map that's showing historical, political boundaries of a country may be less detailed and more zoomed out. Coordinates are also important to consider when making maps, especially from the technical side. You'll find a lot of maps using intersecting planes of latitude and longitude to reflect locations all around the Earth's surface as a data point of these two values. But because the Earth is round and most printed maps are flat, we need to find a way to print these curved features onto a flat plane. That's where projection comes in, a common example of which is the Mercator projection, as we discussed previously. There are actually a lot of types of projections, and you'll find that some countries tend to favor one over others when it comes to designing and developing maps. We also need to consider our use of symbols to describe certain elements depicted in maps. Depending on the information you're trying to convey, certain shapes and symbols may be more appropriate than others. Finally, one of my favorite parts of map making is considering color and typography. Color can be used creatively and functionally to emphasize certain features. A simple map can easily become more striking with the change of a color palette. Similarly, text can make it easier for viewers to understand the information that's conveyed in the map. Now, you may be thinking, how do we actually take all this information and create digital maps? We can use a type of data called geospatial data, which contains location-based information about objects and events that are associated with physical locations on the Earth's surface. This type of data is informative, albeit a bit complex, but we can leverage specialized programming packages in R to neatly extract this geospatial data and create professional-looking maps using a tidyverse approach.